All right, 43. So 43 is really cosine of 2x squared. So f prime is 2 cosine of 2x times, anybody? Negative sine 2x times 2. So f prime is negative 4 cosine 2x sine of 2x. So far so good? All right. So the whole point the last 2 days has been to find where f prime equals to 0. So 0 equals to negative 4 cosine of 2x sine of 2x. Well, negative 4 is irrelevant, because 0 divided by negative 4 is 0. So the question I'm asking is, when does cosine of 2x equal 0, and when does sine of 2x equal 0? Okay. So as I look at my unit chart, what values have a cosine of 0 on my unit circle?
5/2.
Say again?
5/2.
Pi over 2
4 pi over 2.
and 3 pi over 2. So pi over 2 and 3 pi over 2 are when cosine of 2x equals to 0. You agree with that? Okay. We'll talk about just this part now, so we can see it. So this is when cosine equals to 0, correct? But I don't have cosine of x, I have cosine of 2x. So if I divide everything by 2, then I have x equals to pi over 4, and x equals to 3 pi over 4, right? Do you agree with that? Make sense to you? Okay. So there's 2 points where f prime equals 0. Pi over 4 and 3 pi over 4. Now we'll do a sine. Sine of 2x equals to 0 at what points?
Pi, 2 pi.
At pi and 2 pi. Okay. So that's when sine of x equals 0. Divide both sides by 2 and I get x equal to pi over 2 and 2 pi over 2, which is pi. So now I have 4 points where f prime equals 0. They did not give us a restriction on the domain, did they?
0 and 2 pi.
They did say 0 to 2 pi? Okay. I'm thinking I may have a couple of additional points where these guys are 0. Okay. I'm also going to have to deal with the fact that the domain of cosine cosine of 2x equals to 2 pi means that this is a domain now. I'm dealing with a domain, okay? Domain of cosine is 2 pi. I have cosine of 2x, which means 2x equals to 2 pi, which means x equals to pi. So now my domain is, that doesn't sound right. Yeah. So one cycle would happen every pi units. So,
So it's like happening twice is,
happened twice, yeah.
so we're doubling.
We're double.
So everything in between pi over 4 and 3 pi over 4 is also going to be like in the middle of it.
I'm thinking it's beyond pi over 4 and 3 pi over 4, isn't it though? I think it is.
Yeah, it's 7 pi over 4.
So I need to make another trip around the circle. Yeah, this is, since cosine is, since we're going from 0 to 2 pi, we have to deal with the fact these guys are going to show up again. So, it was 7 pi over 4, you said?
Yeah, that's right.
Make sure I want to make sure I'm not lying to you guys here. Yeah, because 7 pi over 4 is going to take us back to that pi over 4. I feel like I am forgetting something. I want to go look at what I did just to make sure I'm not forgetting anything. What number was that one?
43.
43. So these first four right here are for cosine. These first four are for cosine right there. So pi over 4, 3 pi over 4. Let's rewrite this out right here and see if it makes more sense to me. So 0 equals to cosine of 2x. Because the domain has been shifted, we need to have more than just... Oops, I'm sorry, y'all can't see that. Because the domain has been stretched, or compressed in this case, we need to include more than just these 2 points. Okay, so cosine is 0 at pi over 2, at 3 pi over 2, pi over 2, at 3 pi over 2, make another trip around to get 5 pi over 2, 7 pi over 2, okay? And then you're solving all 4 of those equal to 2x. So that'd be pi over 4, 3 pi over 4, 5 pi over 4, is that correct?
Yes.
Okay, 5 pi over 4, and 7 pi over 4 will be your 4 zeros for cosine. So let's talk about why we know to double what we have here, okay? If that, basically, that's one trip around the circle. We're going to be making 2 trips around the circle. If that had been 3, we'd be making
3
3 trips around the circle. Whatever number sitting right here is telling you how many times you're going around the circle, which means that's how many of the original points you want to have before you try to solve. That make sense? Okay. And so then same thing on the sine guy, I should have gone around the circle one more time. So I should have had pi, 2 pi, 3 pi, and 4 pi. Okay. So pi over 2, pi, 3 pi over 2, and 4 pi over 2, which is 2 pi. Why was this one not included? It's out of the domain restrictions, right? The domain was 2 pi non-inclusive. Go back to the original problem. It was 0 to 2 pi non-inclusive of 2 pi. So he's going away. So I wind up with these 4 for cosine and these 3 for sine as my candidates for maxes and mins. Okay? And with, let's go ahead and draw a number line here real quick. So I have pi over 4, 3 pi over 4, pi over 2, that would be 2 pi over 4, pi over 2, 2 pi over 4, right? So I'm dealing with that one. These are cosine. This is cosine, cosine, sine, sine, cosine, 3 pi over 4, 3 pi over 5 pi over 4, 7 pi over 4. I'm missing one.
2 pi.
2 pi not included, but I should have had 7 of them. 4, 5, 6, 7 pi over 2, 3 pi over 2. 3 pi over 2. Which should be right there. That's a lot of intervals to have to check. It's a whole lot of intervals to have to check. So what I have to do is pick a number in every one of these intervals to check, to test.
Can you say if you just did that on the calculator?
For this, I'd be fine with that, yeah. On the AP test, you expect to have 2 or 3 intervals you have to check, not all of these guys.
Well, since it's a wave,
This is a wave, you know what's going to happen. You think you know what's going to happen, but do you know what's going to happen? You may not, because it's sine times cosine. You may not know what's going to happen. Just for the sake of time, let's go ahead and talk about what it would look like. So I've got cosine of 2x. I included the negative 4 on here. The negative 4 doesn't matter because, again, we divided it off a while ago. But this was the original derivative equation. Do you agree with that? Yes. So we graph this guy. Let's set our window 0 to 2 pi. So it turns out it is going to do what you expected to do, Alex. Everywhere it's 0 is changed from a max to a min. Okay? So if we do trace, what is a number left of pi over 4? Pi over 6. That'd be fine. She said pi over 6. So trace second pi divided by 6. That is a...
I thought we were supposed to put the original equation in.
So I'm not interested in the max and the min yet. I'm interested in...
Oh, okay, sorry.
What did the question ask? Was it asking for intervals or was it asking for max and min?
both.
Let's do, I do the intervals first.
Okay.
I'm doing the intervals right now, okay? So left of pi over 4, the parent function is doing what? Decreasing, okay? So left of pi over 4, the parent function is decreasing. So this is decreasing from 0 to pi over 4. We'll be okay with that, because that's a negative number right there, right? If I do trace, a number between pi over 4 and pi over 2. Pi over 3, okay. Pi over 3. Trace second pi divided by 3. That is a positive number. So this is increasing from pi over 2, from pi over 4, rather, from pi over 4 to pi over 2. Increasing from pi over 4 to pi over 2. Well, you can look at this graph and see what's happening here, right? It's going from increasing, decreasing over and over. So this one will be decreasing. This interval will be increasing, continuing. And so you would union all those intervals. So it's decreasing from 0 to pi over 4, from pi over 2 to 3 pi over 4, pi to 5 pi over 4, from 3 pi over 2 to 7 pi over 4. Okay? Those would all be decreasing intervals because you can look at the graph and see that. It would be increasing from pi over 4 to pi over 2, union 3 pi over 4 to pi, union 5 pi over 4 to 3 pi over 2, union 7 pi over 4 to 2 pi. You hear that? So one, possibly more than one, but at least one of these is a max and a min. That's where you go back to the parent function. So I'm going to graph the parent function so we can see it. So we've got, the parent function was
Cosine squared of 2x.
cosine squared of 2x. Cosine 2x. Squared. Turns out they're all in maxes and mins. Every one of them. So any of, so let me tell you how to read this, getting back this chart right here so you know what's happening. The parent function went from decreasing. I'm drawing this picture for a reason, guys. I want you to be drawing this picture too as you're working to help you think about the problem. It's decreasing to this point. It's increasing at that point. What do you suppose you have right there? It's the parent function. You have a minimum in the graph, right? The parent function looks like that. It's decreased. You have a value right there. That's how you can know, is this going to be a min or a max? If we go from decreasing to increasing, it's a min. So if I type in trace pi over 4, that is a min right there. That is, doesn't have to be 0. It could be anything. We don't know what the parent function looks like, okay? We just know it's a min on the parent function. We do the math, it happened to be 0 in this case. But that same exact graph, if I put a plus 5 right here, the derivative would be the same, because the plus 5 is going to go away. But in that case, my min would be, theories? Before I type it in, theories?
5.
Anybody else? 5. Okay, let's make sure. All right. So then this one went from a increasing to decreasing. Theories on what this point right here is going to generate for you. A maximum, right? Because the parent graph is going up and coming down. So anywhere you go from increasing to decreasing, you've created, you're looking at a potential max, a relative max for sure, in your graph. Okay? So trace, if I look at pi over 2, value of 6. So my min is 5, my max is 6. In this case, in your case, min would be 0, max would be 1. That was fun. What else?
45.
45, another trig function. So f prime, so that's f equals to sine of x squared plus sine of x. F prime equals to 2 sine of x cosine of x plus cosine of x. I said it equals 0. I can't solve that yet. I have to what? Reuse.
Take it here.
I have to undistribute, right? I have to undistribute. I have to get down to some binomial terms being multiplied together. I have to factor to get down to terms. Anytime I have a plus or minus sign outside of a parenthesis, that's not a term, right? That's a different term. Doesn't help me out. I have to undistribute this. Give me 2, anybody?
Cosine.
2 cosine.
Or can you take the 2 out? Because
It's
there's
just the.
I cannot take the 2 out, thank you. It is cosine times
2 sine plus 1.
2 sine plus 1. So I'm perfect now, right? Now I have terms being multiplied together. I factored. I can set that equal to 0 and talk about what each term does to me. So this is just sine of x, right? So our domain hasn't been stretched. So all I care about is 1 full revolution on the unit circle. So when is cosine equal to 0? At what point? Pi over 2 and 3 pi over 2. So those are 2 candidates. Those are 2 critical points I have to evaluate. Okay. All right. When does sine of x equal to 0? 0 and pi. Okay. I'm going to bring the 1 over. So -1 and pi minus 1 are my critical points. I forgot my 2. Hold on a second. I forgot my 2. Forgot my 2. So that's going to be -1/2 and pi minus 1 over 2. Is that what they had?
No.
What do they have?
7 pi over 6 and 11 pi over 6.
What do I have wrong here?
Did you have your sine as?
Is 0 not inclusive though?
Yeah, I got points for sine is -1/2.
That's what I'm doing wrong. Thank you. Okay, let me try it again. So 0 equals, I'm trying to do the arc cosine 2 sim. Thank you. Sine of x plus 1, bring the 1 over,
So 1 is equal
divide by 2. Now I can do the arc cosine. Now I can ask, when does sine equal to -1/2?
And can we use our calculator?
You would have to, let's see, -1/2, you would have to know that one, okay? When does sine equal to -1/2? So negative square root 2 over 2?
Yeah.
Would it be 7 pi
Well,
over 6?
That, you're looking, see, this is not an angle, this is the actual value. What I'm looking for is when sine equals at 7 pi over 6. The square root 2 over 2 doesn't help me, it's pi over 6 is what I'm looking for, 7 pi over 6. So sine equals to -1/2 at 7 pi over 6. 7 pi over 6, and 11 pi over 6. So those are my 2 angles when sine is equal to -1/2. So my 4 critical points are pi over 2, 3 pi over 2, 7 pi over 6, which would be
between
in here somewhere, and 11 pi over 6, which would be out here somewhere. 11 pi over 6. And so the intervals that I could test would be left of pi over 2, pi over 4, or even easier probably would be 0, right? Because 0 is in the domain, and that's left. Always pick the easiest point you can possibly pick. 0 is easy, okay? Between pi over 2 and 7 pi over 6, between 6 pi over 6 and 7 pi over 6, yeah.
Between 6 pi over 6, you can't just do pi.
Between 3 pi over 6 and 7 pi over 6. I said that wrong. Between 3 pi over 6,
4 pi over 6.
4 pi over 6, or he said pi would be perfect. Pi would be perfect. Thank you, sir. My mental math was wrong. Okay?
I thought you were like,
Yeah.
knew something we didn't. I was like,
So between 7 pi over 6 and 9 pi over 6. 8 pi over 6, which is 4 pi over 3. Is there an easier one? I don't think there's an easier one, is there? 4 pi over 3. And then between 3 pi over 2 and so between 9 pi over 6 and 11 pi over 6, 10 pi over 6, which would be 5 pi over 3. And again, this would be a calculator problem because 5 pi over 3. I don't think they would give you that one that hard on the AP test. You could find it. 5 pi over 3 is 1 full trip around. That's 3 pi over 3 and 2 pi over 3 more. So that would be, depending what we're looking for here, our function was cosine times sine. So you can plug in both of those into there. Let's use a calculator for right now. So y equals 2 cosine of, now f prime was right here. So I could use any of these three. It wouldn't matter which one you type in the calculator. If you were doing it by hand, you'd use this last one because it's the easiest one to use. Okay, but if you're using a calculator, it wouldn't matter. Cosine of 2 sine of x plus 1. That's not right. Cosine of x. Cosine of x times 2 sine of x plus 1. Okay. And so we can see that left of pi over 2, that's going to be pi over 2. Second pi divided by 2. Left of pi over 2 sorry, I want to type in 0, my bad. So 0 is a positive number, right? Everybody see that 0 is a positive number? So this interval right here is positive from 0 to pi over 2.
But I thought it's decreasing when it approaches pi.
Okay, this is the derivative I'm looking at, right? Every one of these are a positive y value.
So you're not looking at what the graph's doing,
You're looking at, is it above the x-axis
Where's it below?
or below the x-axis? Because the parent is doing this. The parent is increasing. We'll draw the parent up here. So there's an x-axis right there. The parent is increasing to this point right here. So as of right now, that's what the parent did. I don't know, and because it actually looked more like this. It actually looked more like that because we had small slopes, bigger slope, smaller slopes. These y-coordinate slopes, right? This is a small positive slope. This is a bigger, so that's a positive slope of 2. This is a small, that's a positive slope of 1. So it's coming down, okay? At this point, the parent function tops out and begins to decrease. Slowly at first, getting faster, and then slower again. Okay? So at this point, we have a bottom on the graph. Follow me? Now we are increasing very, very slowly to this point right here, popping out again, and then decreasing very, very slowly to that point right there and bottoming out and then increasing steeper at the end. That's what the parent looks like. We good?
C.
Alrighty. We have a quiz for today that we're out of time, so I'm not going to give it to you today. I'll get you tomorrow. Okay. So let's talk about today's topic. Same thing. But now we're adding in the idea of a point of concavity. Concavity. Forming a cave. All right, which direction is the cave being formed? Is it up or down? So if I am looking at this function I gave you, this graph is concave down.
So every max
is going to be part of a concave down. You're exactly right. It is concave down, as best I can tell, from here all the way to right there.
Halfway between.
Halfway between. Halfway between is called a point of inflection. Your notes, I'm on step 4 right now. Point of inflection. At that point of inflection, we go from concave down, and we begin to be concave up. So how can we know that without a picture of the parent function? That's the question.
The max and min.
So the max and min tell you the, so you could use the max and mins,
we need another place.
but we're going to have another tip. We're going to have another process we're going to walk through. You could use the max and mins, and halfway in between that would be the concavity point. I'm going to hesitate to say it's always going to be the concavity point. I'd have to think about that. I think there's cases where it wouldn't be halfway in between. But I'd have to think about that. But here's how we're going to find it. So at that point, right here, what do you notice about the derivative graph?
It's at a minimum.
There's a slope of
0.
0 right there. So follow me on this, okay? Think about this for a second. When I asked you to find the max and the min of the parent, how did you find that?
Make it equal to 0.
Make what equal 0? The first derivative equal to 0.
Oh, boy. Second derivative.
So the second derivative is going to tell me where the first derivative equals to 0.
Gotcha.
Okay, so follow me. All right, I have a parent function. I find the max and the mins by setting its derivative equal to 0.
Correct.
The point of concavity, the point of inflection rather, is always going to be where the derivative is equal to 0. So set the second derivative equal to 0, and that's going to show you the max and the min of the derivative. And so that's going to be your concavity. So if you look at the notes, to find points of inflection, take the second derivative, find the critical points, set it equals 0, find the critical points, and create your little test graph just like you've been doing. That's what we're doing today. So let's go try one out. We're going to do number, I don't have it printed out. Number 11. x cubed minus 6x squared plus 12x. X squared, no, x cubed minus 6x squared plus 12x. I want to know where that has points of inflection and talk about its concavity. Let me graph it first so we have a visual of it. And we can see if our answers make sense. So x cubed minus 6x squared plus 12x. So, did it give us any restrictions on the domain? No. So let's do zoom 6. Zoom 6. All right, so it is concave down for sure at this point. It's hard for me to tell what it's doing down here lower. I'm going to guess at some point it's going to begin to turn out, but it may not. X cubed, it may not. It may just go straight down. I don't know. But for sure, it is concave down at this point and concave up at this point. Do you agree with that?
Yeah, right.
So our point of inflection is going to be right in here. Okay? That's where we're going to go from concave down to concave up. So, first derivative, 3x squared minus 12x plus 12. Second derivative,
6x.
6x minus 12. Set that equal to 0. We get 6x equals to 12, so x equals to 2. We have a critical point at x equal to 2. There's no guarantee because it's a critical point that we definitely have a point of inflection or anything else. You have to test them. But that's our candidate for it. Okay?
Oh wait, how'd you get just to, is it 12 equals 6x squared?
Did I draw up
No,
those?
it's not. Never mind.
He's just an idiot.
Yeah, that's right.
As long as we're clear
No, you're good.
that he's an
I'm
idiot.
making it.
Someone draw my line graph right here. Okay? I'm going to test the intervals around it. So pick a number left of 2.
1.
1, 0 is even easier, right? Pick a number right of 2.
Got him.
70.
70, that's an awesome one. Plug it back in here to f double prime. That's where we're checking, okay? So 6 times 0 minus 12.
Negative.
6 times 3 minus 12. Positive. That's all I care about is the signs. So I have a point of inflection because it changed signs. I have a point of inflection at x equal to 2.
How do you know it's exactly at 2?
Because that's the purpose of this test.
Well, I mean, couldn't it be at like 1 or something, or no?
No. No, that's the purpose of this test.
That's the critical point is to.
So let me graph the.
But I'm saying like, I thought you had. Never mind.
So here's the second derivative right here. 6x minus 12. It crosses the x. It goes from having a negative slope to a positive slope. These are slope values, right? These are negative numbers, right? So on the second derivative, I'm going to graph velocity too, so you can see both of them. So 3x squared.
Well, I'm saying like you could put 1 in place of 2 and
Oh,
have
sure.
3 and then it's still
It'll still be negative, right? If I put a
negative
1,
and positive, so
1 in place of what?
2,
No. If I put a, so at 2, what is the value here?
0.
0.
You want a 0 there?
At 1, it would be negative.
That's the whole point, is you found where the
With the slopes.
slopes are 0.
Oh.
And check on either
That's
side
the
of that.
purpose of this line test. These are where the values are zero.
No.
Everything left of this is negative, which means it is concave. Means it's concave. Anybody? Concave. Concave and left of 2. All of this is concave down. That's down. Anytime you have a negative on the second derivative, that means that is concave down. So this is concave down from negative infinity to 2.
So what if it was negative on the other side?
Negative on the other side of what? Right here?
Right,
Right
if it's
here?
positive right there and it was negative where the 3 is. Like what would it would be concave.
If this was positive,
Okay, so if
if
it's
this
positive.
was positive and that was negative,
Yes.
then it'd be concave up.
Concave up for that
What are they both
section.
negative?
They're both negative, it's not a point of inflection.
So you just say bad.
Wait, why don't you do concave down
Stupid.
negative infinity to concave up to infinity?
I am, I'm not done yet. Concave up
Gotcha.
to infinity. Thank you, exactly right. So there's everything I know right there. The point of inflection is at 2, is concave down up until 2, and concave up after 2. While we're here looking at this, let's just talk about the max and the min of this thing, a relative max, relative min. Okay? So let's go back to this one. Let's just find out relative max, relative min. What you've been doing for the last 2 days.
Right.
So f double prime, 0, 3x squared minus 12x plus 12. Take a 3 out of that. X squared minus 4x plus 4.
X minus 2 squared.
X minus 2 squared.
2.
Okay, so you have a critical point at 2. Left of 2, the sign is
Negative
left of 2.
1.0. Positive.
Positive, right? Negative 2 squared is 4, times 3 is 12, that's positive. Right of 2,
It's gonna be positive.
slope is
Positive.
positive. Was there a change? Is there a max or min in this graph?
Not right there, I guess.
Not anywhere.
Not anywhere.
This is our only critical point.
Oh,
It did not change signs. And look at it. There is no max or min.
boy. Are we doing that?
It's increasing forever.
For you-
Now,
everyone?
you're following the directions. I'm just trying to help you relate what you've been doing.
I need the
Okay?
following students to please come to the front
Look
office.
at me.
Connor Robnett.
First derivative
Austin Warner.
is
Beth Wiggum.
max min.
Dylan Woolridge.
Second derivative is
Kyla Bell. Drew
point of
Vodka.
inflection. They're all critical points.
Yeah.
First derivative is
Christopher
max or min.
Longberg.
Second derivative is point of inflection.
Ray
The
Bynum.
critical points
Megan
should be the
Bynum.
same.
Critical
Abby
points is
Goldberry.
what you get
Tristan
when
Dunlap.
you solve this.
But the critical
And Caitlin Godfrey. If I called your name, please come to the front office.
No, could be different.
Okay.
Could be different.
Just in this case, since it was over.
Happen to be the same, wouldn't always be the same.
They don't do it separate.
I need these things.